Hi there, my name is Mike, and welcome to this beginning masterclass in Git. In this class, we're going to be talking about Git and GitHub. Git is the technology that we're going to be using. It's a source control management system that's used to track changes in files. GitHub is the web host or a remote server where we're able to host our repositories. So it's important to keep in mind that these are two different technologies. What we're primarily going to be focused on, though, is learning Git. Git is a tool that can be used to, again, track the different changes that you make to files over time. This allows you to iterate on your software more aggressively or otherwise collaborate with many other software developers on the same project. The techniques that you're going to learn are the most common ones that are useful to somebody using version control. Things like adding files so that they'll be tracked, committing them so that you have a saved snapshot of your project, and then finally pushing them to a remote server. We're going to start off by creating a repository on github.com, and let's go ahead and dive in and start learning about Git. You're going to want to start by learning Git by having a place where you can host your repository. And we're going to focus on hosting files upstream, that is somewhere on the internet, that is on github.com, which I'm highlighting here. You can follow along with other tools like GitLab, Bitbucket, or whatever the software host of the day might be. But I prefer GitHub because it's also one of the most popular. So go ahead and sign up or sign into your account at this point. Once you've signed up, go ahead and click New and create a new repository. You can find this from your section over here when you click on your repositories and then click a new one. I'm going to call this one Git Masterclass, but you can name it whatever you want. I'm going to make mine private, as by default I always like to make them private. And adding a README can be useful. And my default branch that I want to create is, well, the convention today is to name it to main or something of that flavor. So I'm going to go ahead and update that. And once we've done so, I will create the repository. So if all has gone well, you'll now see your repository created here. Now at this point, GitHub is hosting our Git repository. And we're going to want to gain access to this repository on our local machines. And this is what makes Git very powerful, the technology. Because Git itself is a distributed source control system, or you often see it abbreviated Distributed Version Control System, DVCS. And what this is going to allow me to do is take what's on github.com here and copy it locally to my machine so that I can work on this project with the associated files. And then another programmer is going to be able to do the same thing, either by working on the same code or perhaps using this feature, which we'll talk about, and creating a different branch to add various features to this final software project. So let's go ahead and start with the basics, though, and just copy these files here. And just to make things a little bit interesting, I'm going to go ahead and from the web interface, click on this little edit thing, scroll down, and edit this file here and say, hello from Mike. This is our test project. And go ahead and give ourselves a little note here and commit the changes, just so that there's a little bit of interesting text here. Okay, so we've modified this file. Now let's go ahead and clone this repository so that we can use it from our local machine. In order to do this, I'm going to navigate to the green button here, click on code, and click on the clipboard icon to copy this URL. Or you can double click and right click and hit copy here. There's other options to do this from, but I like using HTTPS to connect here. And now what I'm going to do is switch over to a terminal, which I'll open in my screen here, and clone that repository. So let me go ahead and just set this up here. I'll do git clone, and then I'm going to right click here and paste in that URL so that you can see all of the command here. And then I'll hit enter, and it's going to ask me for my github.com credentials, which is my username and my password, which when you type out, it's not going to echo back. So for security reasons, but then when you hit enter, if you typed in your password correctly, you'll see this message that from a remote, that means some remote location, github.com, your project has been downloaded. If I do an ls here, I should be able to find or navigate into my repository, which was named Git Masterclass. I'll change into this directory and we should see it here. Now, at any point in this tutorial, you're going to see me use a lot of different commands. So what I'm going to do here, just to make things a little bit more clear, in the panel above my head here, is I'm going to go ahead and show you how to use the Git help system in case you need help. So you can type a command here, git help, and then that first command that we use, clone. And we can go ahead and read about what it does. It says we clone a repository into a new directory. So that's exactly what we've done. We've created this repository here using the github.com interface, and we've cloned it or brought a copy down from the web onto our machines. So now we have that repository available to us. And again, just to show what's in this directory, on the left side, you'll see this README, and I can output this file here. And you'll go ahead and see that it has the markdown from our web interface. Hello from Mike, this is our test project. Now, before we start diving into some commands, I just want to illustrate this point again of Git being a distributed version control system. So let's go ahead and draw it out here. And what I often find is beginners sort of struggle with this idea, because up here in the corner, we have github.com. And this is one of the remote servers or somewhere where our repository is being hosted. In other words, it's somewhere where we have a bunch of different files here. So like our README, for example. And within this repository, we can clone it down onto our machines. I'm going to go ahead and draw myself here. Here's Mike, and I get a copy here when I do git clone. So now when I work on this repository, I'm working on a local version here. And that's important. It's local on my machine. So if you, which I'm going to draw over here, this is you, do a git clone of this repository, you'll again have your copy of the file, and I'll have my copy of the file. But you'll again be working locally on your machine. So we're working on two different instances of this repository. That's where the sort of distribution part comes. We're having different copies distributed amongst different people. And that's a good thing in the sense that if my machine has a power outage and the hard drive fails, you'll have an entire copy of this repository, as well as the history of all these files, which we'll talk about. But what this means for us as far as collaborators is anytime you make changes, you're going to have to push them to the same repository, which lives up here, just as I'll also have to push those changes. And as well as pushing changes up, which we call upstream, I'm going to write that up here. This is upstream, where we are pushing things up to the clouds, if it's helpful to think of it in that way. Then we'll also have to pull down the files. We did that once with our initial clone, but every time we want new data, we'll have to pull that data down. And that new data could be changes that you or I or any of hundreds or thousands of other developers are working on in this repository, or otherwise from this remote source. So now that we have a little bit of an idea of what's going on here, let's just get comfortable with some of the commands in Git and practice. Okay, I'm going to go ahead and switch to my terminal here. And just to make things interesting, let's go ahead and create a new file here. I'm going to go ahead and add a file here. I like programming in C or the C++ language. And, oops, I got a little bit ahead of myself. Let me just create a file here using my favorite text editor, Vim. And what I'm going to go ahead and do is just create a little hello world program here. Hello world. So this is interesting enough. And if you've taken a C course, this should be relatively familiar. And we can go ahead and compile it just to make sure that it works. Let me just go ahead and do this. And almost. Let me get rid of the compilation here. There we go. There we are. Hello world. So easy as that, with a few tiny mistakes that I've sprinkled in. And, well, we've written some software here. And now we can imagine that we're really impressed with this program, our hello world here, and we want to save those changes. Now, I've saved them locally on my machine in the sense that if I do an ls, I have this main.c program that exists on my hard drive. But what if I make some changes to it? So for example, I add hello world, and let's go ahead and add some other notes here. This is about Git. And I can again save these changes, recompile, and rerun this program, and we can see that it's progressing forward. But again, I'm just saving locally. And we want to take advantage of version control. That is having a history of our files. So I'm going to draw this out in another way here. So here we've looked at our sort of distributed system here. And within this system here, our repository, whether it's in the cloud or locally, we have a bunch of files here. And I'll go ahead and just draw it down here. Main.c. And every time I save, right, that file exists somewhere in here. But what I really want to do with version control is have the different versions as I add or change the contents of this text here. Okay, so these might be the different iterations of my program where I add or remove some text. And that's what really makes Git valuable, that I can always rewind in time if I've made a mistake or want to revert back to previous version. If you've used tools like Google Docs, Dropbox, Apple Cloud, Microsoft OneDrive, etc., these tools have that feature built in when you go and look at the version history of your files. And maybe it's saved you before if you've accidentally overwritten or deleted a file. So let's go ahead and start tracking this file here so that we can have versions. Because remember, we're in control. Git is a software, and we're going to tell it how to do the version control for us. So how do I do this? Well, the first thing I'm going to do is introduce to you a command called git status. And this is a helpful command because at any point in time, it'll tell us the status of our repository, meaning what's going on, what files are we tracking. So if I navigate into my Git directory, and it has to be in a Git directory, so let me make sure I do that, an ls just to see the contents, and I'll run git status. We'll see this message here. It says we're on this main branch, which we'll talk about branches, and we have some untracked files. That means there's files that exist in our local repository over on this side here, and we're not tracking them from within this Git repository. Okay, so how do we do that? Well, what we're going to do is type git add and then main.c, which is the file that we want to track. And then I'm just going to rerun this command, git status, and we'll go ahead and see some of the changes here. So now it says here, our branch is up to date, and you'll notice in green, we have a file here, and it's under the changes to be committed category. We still have an untracked file here called prog, and I'll talk about that in a moment here. But let's just worry about one file at a time, the main.c. So how do I save this file in our version history? Well, I do git commit -m and then a message. The -m is the message flag. And this states something that could be helpful for us. So created our main.c program to say hello. And I'll make this just a little bit smaller so you can see more on the screen. And there it is all in one line. And I hit enter, and then you'll see this message created our main.c program to say hello. And then that there was one file that was changed, and we did 9 insertions, meaning we changed either 9 lines or 9 characters or something different about this file here. So if I go ahead and look at our file here, I see 1 through 9 different lines here. So at this point, we've created a snapshot of our program. It's part of our history now, once we've done this commit. So the main.c file is being tracked. So if I run git status again, and let me close out Vim when I do this, you'll see, I guess I made one more change in this file here. I made these uppercase, so let me go ahead and get rid of that. There we go. So no changes in that file now. And you'll run git status, and it'll always alert you now that we are tracking that file in red if some file you've since saved or modified, but you haven't tracked the changes. So it's not part of our commit history. Okay. So what about this other untracked file here, this prog here? Well, this is a binary file. And we can get prog, this binary file, by, well, on my left side here, just compiling the source code. So we don't really need to track versions of this file because it's constantly going to be changing and we can generate from our source code. So typically in GitHub repositories, we don't track binary files. Okay, so now we have an idea of what's going on here. So I'm just going to go ahead and remove the prog file here, and I'll run git status. And again, it says that we're on branch main, and now it's giving us this message that says we're ahead of our origin main by 1 commit. Well, what does that mean? Well, what that means is we've committed or saved a snapshot of our project, that is with this main.c file, but we haven't pushed those changes back up to the cloud. Remember, we have a distributed system here. So on this side here, this cloud here doesn't have the main.c file. In fact, I'm going to prove it to you right now by showing you that if I refresh github.com, we don't have main.c because, again, I need to push those changes up into the cloud. So let's go ahead and do that. So in order to do this, I'm going to go ahead and just type git push. And it's going to ask me again for my github.com credentials, which I'll type in. Hit enter. I'll paste in my password. And with all due luck, you'll see that there's some compression going on to make our files nice and small. And then they are sent to HTTPS and the username, your GitHub username, and the repository that we created. So now if I go online and I refresh, we'll see main.c has been pushed up to the cloud. So this is great. We now have our files pushed here. And if somebody else clones our repository, they'll get this snapshot here where they can see our main.c file that we worked on locally on our machine and any other changes that were made. And in fact, you can see in the history here, if you click on the commits, that these are the ones that we've made. And you can see these different insertions or deletions if we've removed lines of code here. And they're usually highlighted in green with a plus symbol here. So that's very helpful. And that's what we can see from the web interface. Now we can see those same changes on this interface as well. Because again, we have that whole commit history on our machine. So if I run git log, for example, and I like running it with the one-line command here, we'll see the different commits that we've made here. If you just run git log, you'll see the different commits with the different changes that were made and so on. And they have a specific ID associated with them. And these are the IDs that you can use, for instance, to roll back your changes if you like. So just a quick recap of what we've talked about. We can do git status to check the status of our repository, git add to start tracking a file, and git commit to save a snapshot or a rough draft of our project. And then we can push those changes up. We can also run git pull if other changes have been made. For example, if some other developer has worked on this repository as well and pushed their changes, we'll want to run git pull. I can hit enter, and if it's already up to date, it'll be up to date. Now, just a few things that are going on behind the scenes before we move on to one of the next topics on branches, and then we will end this series. So something that we can do is to look at what's going on a little bit behind the scenes here. Now, if I do an ls here in this Git repository, how do I even know it's a Git repository? How do I know what's going on behind the scenes? Well, I can actually look at hidden files here. And ls command with L for listing the files, all the files, and all the hidden files will display that there is a .git directory. Directories that usually start with a dot are hidden. So if I see into this directory, the .git, one, I know that this is a GitHub repository. And then I can do ls, and then you're going to see a whole bunch of other folders here that are a little bit mysterious. And if you want, you can look at these in various different ways, like running the tree command, and see all the contents within these different folders here and how they're spread out. Now, You don't need to modify anything in here. In fact, it's relatively dangerous to do so, so I wouldn't touch anything in here. But I want to show you that Git is really just a file system. If you're wondering, how do these changes get tracked? What happens to our commits? Well, in short, for this lesson, they're saved in various locations, the sort of blobs of data, the objects here. And this sort of captures our working state, or what we call a working tree of our directory every time that we do a commit. So that's just a note on this. Now, let's go ahead and talk about a few other items here. So the first thing I want to do is go ahead and talk about how to revert changes. And this is just one technique here. So let's say I start working on this main file and I add a bunch of stuff in here. I accidentally save this file. When I try to compile my program, I notice it's crashing. And I say, why on earth is it crashing? It was just working. Well, in this case, what I can do is do a git reset and then hard. And what this will do is revert back in our history. So if I look at our git log, we'll see that we went back to this latest change here that showed where we created our main.c program. So now if I open main.c, and let me go ahead and open it on the right side, you'll see that this error here that was at line 7 that we added is no longer there. We've reverted, or in a way checked out, a previous file from one of our rough drafts from our commit history, this version of main.c that was working. That's one such technique that we can use. And that can be sort of a get out of trouble card for us. There's other techniques that we can use, and we can revert back as many commits as we would like, for instance. Another technique that I'd like to teach you that involves reverting from changes that you'll commonly do is to work on a particular version of a file. So there's another way that you can do this. Let's say that you make some changes here. And let's just go ahead and change this file enough so that it's different. And let's go ahead and check our status. We see that we've modified this file here. I'm going to add those changes and commit them. Main.c experimental changes, just to see if we like this. And we've made that commit. So now this has been saved. It's in our Git history. But what we might want to do is check out a certain version of that file. So what we can do is go in our Git log, and let me go ahead and use one line and the particular file that I want to look at here. And we can see the two different versions that we have here. And maybe I don't like these experimental changes as much. So what I can do is run git checkout. And if I do main.c, this will check out the current version from the head here. Head, if we think about this as a linked list, is our latest commit, which appears at the top here. It's the head of the list or the top. But if I want, I could check out this particular commit here using this ID of this particular file, again, as a way to rewind in time. So typically how I would do this is I could either check out the current file, or I can provide an ID here. So let me go ahead and provide the ID here. And now if I open my file here, you'll see we're back to this previous version without all the experimental changes. So again, I can look at my Git log here, and depending on which version I like, I can check out back and forth between them. So if I just run git checkout here, let's see what happens with main.c. Well, it's the current version that we have. Or again, I can use a particular ID. Let's put those experimental changes back for this file. And if I look at it again, you can see the ID. So checkout's a way for us to grab files from our repository. And again, if you want to see some more information, git help and checkout. So what we've done is restore working tree files. That is files that are saved. Again, if you think about this as a sort of linked list with a sort of head and sort of grabbing different files based off of the commits, that's what we're doing, checking them out. But there's this other part here of git checkout where we're able to switch branches. And what is a branch? Well, a branch is another way that we can work on Git code. And it's very useful for branching off and implementing features. So allow me to illustrate here. So from our little drawing here, we've been working on the main.c file sort of incrementally. But let's say some other developer wants to work on this particular file or another of a collection of files here. They can branch off and create a new branch here and give it a name, say a new feature, and work on the file here while we progress, make changes here on our files, and then later on, we can merge them together. So we have our collection of files here. Okay, so let me go ahead and show you how to create a new branch. And this is a common workflow because it allows you to work on separate files without stepping on each other's feet, in a sense. So back to our terminal. Now, before I proceed with this, let's just go ahead and push our changes from our latest commit. Paste in my password. Oops. If you make an error, you'll be reprompted to push again. And go ahead and paste. And we should be in good status here. I always like to make sure that I'm in a good status before I proceed forward. Okay, but we're on the main branch here. So how do we create a new branch? And again, just to reiterate here, everything is up to date here. And here we're seeing we're on the main branch. Okay, so we can just type in git branch and you'll see that we have one branch here. If I want, I can create a new branch here called git branch and then name it new feature. So now if I type in git branch, we'll see that we have two different paths that we can develop on. And I can actually switch to that branch by using that checkout command. So git checkout new feature. And then if I check the branches, well, we're on new feature. So effectively, when I've created a branch, I've created a copy of our repository at that particular state and time. And now I'm able to branch off and do development in a different way. Let me demonstrate. So if I run git status, this is another helpful technique for seeing which branch we're on at a given time. And we are on, again, the new feature branch. So let's go ahead and create a new file here. So if I go ahead and look here, I'm going to create the fun.c branch and just create a new function here. And it's just going to print off function here, like that. Okay, so we can see our status. And we've created a new file, so we need to start tracking it. Git add fun. And we are going to, now that we've added it, it's staged or it's ready to be committed. So that means saved in this rough draft. Here we have. So new fun.c file added in new feature branch. Okay. And let's go ahead and see what's happening here. So at this point on this branch, I have fun.c. Now, if I switch branches, say if I check out back on the main branch and I do an ls, the fun.c file all of a sudden is gone because we're on a different branch, a different workflow. If you want, you can think of this like when we do a branch of creating an entire directory. And when you do the creation, you get all those files at a given time. But once you start adding new files in that directory, you're going to need to merge them together. So how do we do this? Well, first and foremost, let's go check out our new feature branch. And before we even get to this, let's say as a developer, I'm going to be working on this branch for a long time. I might want to also send these features upstream. So how do I do that? So in order to do that, I need to run git push -u for upstream, or you can use set upstream. But I like using -u because it's a little bit shorter. Origin, and then the feature branch. I'll type out my name. Let's see if I have my password saved. And it's going to go ahead and push this branch upstream. So let's go ahead and refresh here. And now we'll notice we have our main branch, but I can also go to my new feature branch here. And you'll see that this one has the fun.c file. So again, now different developers can work on different branches without stepping on each other's toes and develop these files. And then comes the part where they do the merge. So I'm going to show you how to do it from the command line, but there's also a feature you can do this on github.com, which will allow you to compare these different branches, meaning what's different, meaning one has the fun.c file and one doesn't, and merge them together. Let's go ahead and do this from the terminal so you understand how this works. So if I want to merge these branches, well, let's see what branch I'm on. I'm on the new feature branch. So I'm going to go ahead and check out the main branch. Git branch, and again, it's highlighted. And then I can run a command called git merge. And the branch that I want to merge in is called new feature. So I'm going to go ahead and do that. And you'll see that the fun.c file has been added with 3 insertions or 3 lines of code here. And if I run my git status, I'm going to then push these changes forward. When I run the git merge command, that's essentially doing the commit as well. So let's go ahead and push these changes. And now, if I refresh here, I've taken care of the merge, so you've seen that go away. But if I go to my main branch, now the fun.c feature is there. So pretty cool. This is how developers can work together and on different branches at different times. Now, let me show you how to fix one thing that is the dreaded merge conflict. So let's say we have 2 developers working simultaneously. Maybe one is working here on the web interface for some reason, and they create another duplicate of this function here. And I'm just going to say that they add something here. And let's say simultaneously, I'm working over here on this code here in our function. And I do something like this. I create another function called bar. And, well, you get the idea. The files are different. So at this point on the web interface, I've made some changes here. And on my local machine here, because remember the system's distributed, I've made some changes. So if I do a git status, we're both working on the main branch. So we're going to have a conflict and potentially, because we are working on the same file. I do git add here, and I commit, added Mike's changes. And usually you want a descriptive message, why I did it, how I did it, etc. But I'll leave it at that. And let me try to push. So I'll do my name, paste in my password. Oops, let me make sure I get my right password. Okay, so let me just push again and put in my password. And it says changes were rejected because what's upstream is different than what's on my local machine. So I need to first pull those changes in with my name and my password. And now it's going to bring in these changes here. And if they conflict, I'll have to resolve them. And usually it'll take you directly into Vim so that you can resolve them. If it's smart enough, it'll figure out, and you'll see that we end up with 2 of these functions, bar and the different functionalities. But typically, that's how we would fix the merge conflict manually on our machine when we pull in the changes, and then we would push them upstream. So this time it was smart enough to show you. But in a moment, let me go ahead and show you an instance where it's not smart enough. Now let's go ahead and try to cause some trouble here. Let's cause a merge conflict so you can see what happens. So let's go ahead and first look at what branch I'm on here. I'm on the main branch. And what I'm going to want to do is create another branch here. And I'm going to go ahead and call it merge conflict branch. A bit wordy, but you get the idea of what's going on here. So as soon as I create that branch, again, that's a snapshot of everything that we had in our main branch. Now let's go ahead and switch to that branch by checking it out. And Git's pretty smart. You can use tab to autocomplete. And now we've switched branches. And I'm going to fundamentally just change some things about this code here. I'm going to add some arguments here. And maybe we want to do C style arguments. Let's go ahead and change this code here. So it's, let's go ahead and change this so it's about Mike here. And again, make some fundamental changes here. And maybe we'll add a function here. And the goal here is just to do enough work that you can imagine that a developer over time has been working on this code for some period of time here. just to make things kind of interesting. So foo is here. And let's see. Here's some actual C. Okay. So there's some interesting enough code here. Now, this is on my merge conflict branch. So let's go ahead and add whatever the changes are, which were in main C. Commit those changes. Code updates. I'm going to make this message purposefully ambiguous, so it's not useful, which is a problem. And let's go ahead and push these changes here. Now I need to follow the directions here to push upstream here, because we've just created this new branch. So I want to push that upstream with the actual branch and the changes here. So I'll need my username and my password, which I'll paste in here. And now we see that the branch has been pushed up. There's a new branch, merge conflict branch. So if we go ahead and look in our repository, there is a new merge conflict branch. Now, in the meantime, let's say that another developer is working on this project. So let's go ahead and from our Git interface, from the main function, let's go ahead and make some modifications here. And at this point in time, a merge conflict happens when another developer is working on the same file. So let's say they write their other function here, foo, and it's actually going to print out something. And perhaps they write another function here. Now, at this point, this would not be valid C code because of the same function name and the parameters, but I'm just trying to sufficiently make this code complicated so that Git can't resolve the merge conflict. So I'm going to go ahead and commit this change here. Okay, and I've been working in the main branch, and now I need to see if I can merge these changes from my merge conflict branch. So let's go ahead and pretend that some time has passed, and the developer who's working on their own feature on a separate branch decides that they need to pull in some changes. So what are they going to do? Well, their branch should be up to date. So if they're doing pull, this should be okay. So I'll type in my name, my password, and let's see what happened. Nothing, because our branch is okay. Now, what happens when we go ahead and check out to the main branch here, because we're ready to implement our feature here, or whatever code changes we've made. So again, just as a refresher, git branch to see which branch we're on, and then we're going to move to the main branch. So we check that out. And it says, okay, our branch is behind by 1 commit, which basically means that here, this code that the user was making, some other developer on our upstream repository, has been changed. So we say, okay, let's do a git pull. No problem. And we get the associated changes. So no problem. But now I want to merge in my feature. So I type in git merge and the branch that I want, which is the merge conflict branch. I'm going to attempt to merge here. And now we get this message here, conflict. The content, where there's merge conflict content and in which associated file. So the automatic merge can't occur. Again, sometimes Git's smart enough to say this function's different or these pieces of the file are clearly different, so it can merge them in together nicely. But in this case, we have to manually inspect what happened. So I'm going to go ahead and look into our main.c file. And it's going to look a little bit weird, but Git has modified what's in the head or our current repository with what is in the other repository. So you're going to see some code duplicated here. And at this point, Git is asking us to make a decision and say, well, which one's really the truth? And we need a human to decide. So you and your teammates or whichever engineers or project managers you're working with need to decide which feature is the real feature. So I'm going to go ahead and pick here. I'm going to get rid of this, which is in my current branch, and this piece here. And I might also make some other decisions, as I mentioned, and say, well, this isn't really a function. So this is the truth here. And maybe make some other modifications to this code here. Ideally, not too much. I would just be fixing the conflict. So there we are. And now if I do git status, it'll say, okay, both of these files were modified in our different branches. So now I can add it, commit it, fixed, merge, conflict, and now push the change. with my username and my password. And now we have a version that has been successfully merged. And I can look on the repository online, github.com, where I've pushed my changes, and I see that I fixed the merge. So I can also look at this file's history here if I click on it and click on the history on github.com and see where some of these changes were. Another useful tool that's available on Linux and others is the gitk tool that you can run from your repository. And it'll give you a little bit of a visualization here where you can see the different branches. Rather than me sort of finger waving along the different directions, you can see which was the branch of merge conflict and where it differed from main. This could be a helpful tool, just something I want you to know that's made available. So with that said, I hope you've learned some of the basic features of Git, and even a little bit about the internals as you can kind of think about Git as a file system. In fact, that's one of the reasons Git can work so fast and you can switch and create these branches. So I hope that was insightful for you, and perhaps you'll visit another video soon to learn more from me. Thank you for your time, and we'll see you again soon.